Now we're at part 2.3, more on data types. Now, I hope you took some time to go back and get familiar with what we've already gone over. You have to practice. You have to read the documentation. It's up to you. So now let's get into the next part. Let's get into it. Now, 2.3, more on data types. Let's get into the curriculum. 2.3.1, arrays. In Java, an array is an ordered, fixed-size collection of elements. To comply with static typing, the items stored in an array must all be the same data type. We can create an array of integers or an array of strings, but we may not create an array that holds both integers and strings. Now, if you're coming from JavaScript over here to Java, this is different because in JavaScript it's dynamic. An array can hold any data type and it'll be okay, but not in Java. If you assign it strings, they all have to be strings. If you're going to assign it numbers, they all have to be numbers. But pay attention here because we're just laying the foundation right now. So later on, once you understand this concept, we're going to introduce another concept to you later. So here, the syntax for creating an array capable of holding 10 integers is an int, and you notice it has the array sign, the brackets behind it, and then you give it the variable, a name. You name a variable, and then you do new int, and you pass in 10. This is how many integers you want it to hold. Note the square brackets next to int. This tells Java that we want some ints to store a collection of integers. Remember, this is what we're doing, collection of integers. Think like the compiler instead of a single number. So this lets the compiler understands when it sees this syntax that we're looking for a collection of integers. If I just wanted one, I wouldn't have the array brackets there or the square brackets there. To create an array of different size, replace the number 10 in the brackets with the desired size. To create an array holding a different type, replace int on both sides of the assignment with the desired type like double or string. In addition to the example above, we can initialize an array using literal expressions. And this is where the curly braces come in. Looks like an object, right? So this is all a part of the arrays. Everything in Java is also an object as well. So this is not far-fetched, okay? It's not to confuse you because everything in Java is an object, just like everything in JavaScript is an object. Here, the size of an array is implied by the number of elements in the literal expression. Remember, this is a literal expression. Remember this term. Understand this term. Also, note that the use of curly braces instead of square brackets. To access array elements, we use square brackets and zero-based indexing. So if we want to, right here, access it, like I said, bracket notation and dot notation, those are access modifiers, okay? Arrays in Java may not change size once created. This is limiting and not very practical. Thankfully, Java provides more flexible ways to store data, which we will explore in later lessons. These objects will all allow us to rearrange, add to, or remove data. Aside from using arrays to build some simple loop examples, we will only use them in special cases. However, they are a core part of Java, so it's good to know how they work. 2.3.2, Java objects. In Java, objects are structures that have a state and a set of behaviors. The state of an object includes properties, data that the coder can define and modify. Behaviors are actions that run when requested, and they can be used to evaluate, manipulate, or return data. An array is one example of an object. It contains data, which are the values stored as the individual elements. The behavior or methods like sort, you're familiar with the sort method, that performs actions related to the elements in the array. The string data type is also an example of an object. The string language assigned Java, the data would be the characters. The string manipulation section gives several of the behaviors available to the language object. For example, language.length returns the value 4. Now notice here, this has parentheses. So if you're coming from JavaScript, this may confuse you a little bit. Notice it had parentheses behind it. That's a method, not a property, which tells us how many characters are present in the string. Every variable in Java refers to either a primitive data type or to an object. So here in the string manipulations, we broke that down, okay? So go back and read that if you didn't. 2.3.3, class types. All right, under the class, a class is a template for creating objects. We call it a blueprint. In addition to the object types introduced so far, any class in Java also defined as types. We have much more to say about classes and objects, but for now, you need to recognize that the basic syntax of a class type and class creation. If we have a class cat, we can declare and create an instance of cat using the new keyword. We're familiar with instantiating a class. Cat, my cat, declares the variable my cat and sets it to be the type cat. Assign new cat, initialize the variable with a new cat object. Any argument that are required to build the new cat object must be included within the parentheses. Just like a variable can be declared as a primitive data type like char or double, it can also be declared as a specific class type variables that holds objects like strings, Blake, like string name, Blake, or my cat, are said to be reference variable. All right, this is something you must remember. Reference variables. When I tell you what a reference variable is, this is what it is. Using this terminology, name is a reference variable of the string class, and my cat is the reference variable of the type cat. No, Java uses two general data types, primitive and object, a class type and a new data type. Instead, it is just a specific name applied to the more general object data type. Int and char are both primitive data types, but the values they can store different. Similar, string and cat are both object types, but they represent different classes. 2.3.3.1 reference variable. All right, so we're about to explain reference variables here to you. All right. Hold on for a second. All right. 2.3.3.1 reference variables. Reference variables are different from primitive types in an essential way. A reference variable such as my cat above does not actually store the object in question. Instead, it stores a reference to the object. See, when we start getting into the memory of how the computers work, when we're dealing with binary numbers, we have everything is stored in memory. And there's different ways that we can point to that memory, and sometimes we can point to memory by reference. And this is what we're talking about right here. It stores a reference to the object. But understand that it says here, does not actually store the object in question, just a reference to it. So, which is literally a memory address. We visualize a reference as an arrow pointing to the location of the object in memory. All right, that's something that has to be illustrated to you because you might not be able to get your hand around what we're saying. And I'll create down the road on binary code on memory, on how things are stored in memory. And I think I did a little video on there when I kind of, I'm going to make another video because I did one at Launch Code where we talked about binary numbers and we were talking about storing stuff in memory. I will break that video down a little bit better for you so you can kind of visualize what we mean here. So consider this code. We got an int, first cat age 11. Int, second cat age, first cat. So we're just passing in first cat age into second cat age. Cat, my cat is the variable and we get an instance of the cat, a class. And then cat, now we're sending the same cat, my cat to the same cat variable. So we declare that. Visually, we can represent these four variables as shown below. Int, first cat age 11. Int, second cat age 11. Same thing. But then we have a cat, my cat variable declared in same cat variable, getting a reference to the same cat data, as you see this diagram right here. So go over this again because you may have to get your head around what it's really saying. So go back and read this again and take your time to make sure you understand what's going on here. All right. So since int is a primitive data type, the variable first cat age and second cat age functions like separate boxes. So let me scroll up a little bit. See, they function as separate boxes. One variable is first cat age. The second one is second cat age. But if you look at it right here, we're storing first cat age and second cat age. Now, an integer value 11. On the other hand, my cat is a reference variable since it refers to the object of type cat. The variable actually stores the memory address of the object, which we visualize as an arrow pointing from variable box to where the data is stored. Right here, the cat data is stored right here. Cat, my cat, same cat. And so here I got cat, I initialized the variable my cat, and I'm creating a new instance of it, so it's stored there. So now I'm taking my cat, which is storing the instance of, or the reference of the my cat, new cat class. Now I'm storing it in the same cat variable that I, using the cat initialize it as I declare it with the cat as the same cat variable, but it's the same data. That's why I say go back and play around with this if this is not making sense. When we assign my cat to another variable as in cat, same cat, assign my cat, we do not create a second copy of the object or its data. Instead, we make a second arrow pointing to the same memory location. This distinction between object types and primitives is important. If subtle, as you continue learning Java, you will see that objects types are handled differently in essentially and important ways. 2.3.4 static methods. If you are familiar with another programming language, when you most likely define and call functions as a pure object-oriented programming language, Java also uses functions, but it structures them in this very specific way. In Java, function may not be declared outside of a class. That's the difference here is what I want to explain to you. In JavaScript, we can declare functions outside of other functions. They can be standalone and all we have to do is call them and we can call them anywhere. It doesn't follow the sequence of a DOM. It can be called at any time. But here in Java, we call them methods because they're a part of the class. They're a part of the object. That's why we don't call them functions because they can't work standalone. Hopefully that makes sense. Rewind the video and pay attention to what I said. If that didn't make sense, go over it again. So a simple function that checks if an integer is even needs to be defined within a class. Within the context of a class, functions are referred to as methods, and we will adopt this terminology from now on. So like I was saying, you was hearing them say functions early on. There are no functions in JavaScript, in Java. They're methods. So, warning, be prepared to receive a vocabulary lesson from veteran Java coders if you accidentally refer to methods as functions. Something that I mentioned early on, so we're reiterating it here. We'll dive deeper into classes and objects in Java soon enough. For now, we will explore how to write methods. In particular, we will use static methods. A static method is one that can be called without creating an instance of the class to which it belongs to. Example, define the class cat and include the static keyword before the make noise method name. So here we have the class cat, and then we have public static void, make noise, string array. So we know we're going to have an array here, a collection, and we pass, all right, this gets passed in. This is the syntax right here, and then we write our code. Since make noise is static, we do not need to create a cat object to access it. Instead of doing this, here, my cat, new cat, create a new cat object. My cat make noise, we pass it here, per, calls the make noise method. We call it and it purrs, right? So now let's say we have a class or a superclass of animal, but then you have different subclasses of different animals. So let's say feline. Feline can have, it's the main class. It makes a noise, but we don't know what kind of noise because we may have subclasses like a house cat, a lion, a tiger. They all make different sounds, but I still want to have access to that method. So now when I have the class cat and I want to reference that make noise that's from the superclass feline, then I can just pass in right here the argument per. If it's a lion, it roars. I don't know what a tiger does. I guess that roars as well. We can call the method directly. Cat make noise, roar. Until we get further into object-oriented programming, every method you write should use the static keyword. Leaving out static will prevent or complicate the process of calling the methods you define. So remember this syntax. This is how you write that syntax. It's important, right? So here, 2.3.4.1, static method examples. Let's examine two classes. In Java, to explore defining and using methods, the first class is defined in the hello methods.java file, and it has a main method. The second class is defined in a separate message.java file, and it contains a get message method we want to call from within main. Here's the examples. Hello world methods. That's the class name. Public static void. We got the main. We passing in a string array args. String message. Message.get message. FR. System.out.println message. So we're going to print that. Now we go over to the message.java. So we got the hello method, right? Now we're in the message.java. So here's the class. And notice that your method here is, the public static is get messages. We just do string language, right? So if lang.equals sp returns hola mundo. Else language equals fr returns bonjour le monde. The mode. Bonjour le monde. I don't speak French. Else return hello world. So now I'm getting access to this language up here because I have the string message and I'm passing in get message. And then I'm using the get message right here inside of my message class. And now I have access to whatever this message is printing out, the string message. I have access to that now. All right. We won't explore every new aspect of this example, but instead focus on the two methods. Number one, the main method in the hello methods class has the same structure as that of the temperature conversion example. Take a look at the message class. Note that it does not have a main method. So let's look at here. It doesn't have a main method like this one does, okay? Notice these differences. So it can't be run on its own code within the message class. Must be called from elsewhere in order to execute. And this makes sense later on because I can print this out. So for instance, if I go over here to temperature conversion, and I come down here, and then we told you how to run it, right? It told us to run it. Okay, it doesn't show me here. So what I'm going to do, let me go ahead and pull up an IntelliJ. And let me go temperature, yeah. So you see how I got public class, public main void. I can run it right here. You can't do that with just, if it doesn't have that a static main void main, it won't run. You won't be able to run it. That's what that means. All right, so the message class contains the get message method like main. It has the static keyword. Unlike main, get message has a return type of string instead of void. So we have those returns here, but void, we don't have. When you have that void, that means it doesn't have a return with it. Get message takes a single string parameter length. Since Java is statically typed, we must declare the data type for each parameter and return the value. This is what we're doing here. This is the example. Public static return data type, method name, parameter name, right? Parameter data type, parameter name. One consequence of this is that a method in Java may not have a return statement that sends back different types of data. Note that lines 6 and 8 and 10 in message Java each return a string. If we try to replace line 10 with return 42, we would generate an error right here because these are all strings and they're not numbers, they're not integers. Okay, let me see. To call a static method, we follow a specific syntax line 4 in hello method Java that shows this: message, get message, FR. To call a static method, we must use the format class name, method name. This is the class name. This is the method name. And then we pass it an argument. Note that get message is not defined within the hello method class. We can do this because get message is declared as public. If we want to restrict the method from being called by another class, we could instead use the private modifier. We will explore access modifiers in more depth in coming lessons. Warning, as you have been following along with these examples, you may have noticed that each class file for the example message.java and hello methods.java is named exactly the same as the class it holds, message and hello method respectively. So the class name up here, right here is what we're talking about. Right here is what we're talking about. It's the same as the class name. So look at the both of them, compare the two. It is a rule in Java that a file containing a class marked public must be named the same as that class. So here, open the Hello World method message file in the Java Web Exercise Project IntelliJ and experiment with the following. Figure out how to alter the Hello World method code to change the message return. Add another Hello World language option. Change one public keyword to private to see what happens. Repeat for each occurrence of public. And here's some documentation you need to go and read from Oracle. Now we made it to the end of this section. Check your understanding. I want you to try this on your own. So go to the file in IntelliJ and work with it. Now, like I said, we made it to the end of this particular section. We're getting ready to go into your exercises, which you're going to do on your own, and you're going to do your studio. Now, with Launch Code, we have studio section. If you're following me on Evolvify, we also connect and we can do the studios there. If you go ahead and go to my Discord channel, and we can work through the studios there together. So remember, that's the end of this video. I'm done with this chapter. I'm getting ready to go into chapter 3 next. So remember, the more you practice, the more you improve. All right. See y'all later.